helped any at all. I desperately live off of questions and interaction, and don't feel like any question you have is not worthy of being brought up. Because I always say, if you have a question, at least 8 other people have the same question. If you speak up, you could be their hero for the day, right? Is that all? I can't read you guys with anything. Okay. So the last topic for today is kind of like everything we've been doing so far is investigating the first skill we need to do the first big calculus thing, which is get a slope function. So I don't know if you guys remember, if I have a function that's just all over the place, I can't just get a slope for it like I can for a straight line. I can get a slope for a straight line because it never changes. So I have the slope of a line. I can't have the slope of this. It's the minute I moved a little bit, it's different. It's different now. Now it's different. Now it's different. Oh shit. So the idea of a limit, I've already kind of shown you. I kind of started with this as motivation for investigating limits. Is there what helps me merge algebra with curves, right? Merge this algebraic concept of slope with curves. So if I have some function and we want to know,
this is 2.7, right?
yeah, 2.7. We want to know the slope of f of x at some point A. I personally really dislike the way that they do 2.7. I'm going to show you what they do in 2.7. I'm going to show you basically the real way to do the general idea, which you can then just plug a number in and get what they get in 2.7. So I'll get to where I'm going. One way to do this, we already kind of looked at this idea. So I have some function. I want to know the slope at some point A. I want to know what this slope is. So one way that's less often used, because the algebra involved in doing it gets very difficult very quickly, so I'll just do this once just to show you what the book's talking about. You pick a point x close to that A, and then you investigate the limit as x goes to A. You look at those 2 points and you let them get close together. So I want to know the slope at A, so I pick some x that isn't A. So then I have 2 points. I have A comma f of A, and I have x comma f of x. So what would the slope be between those two? y2 minus y1 over x2 minus x1, right? Trying to be an A there. All right, so we've seen that before. I threw that up there because I thought it was important. That's calculus. Then we investigated limits. Now we're coming back to this, and we're going to apply everything we know about limits to this. To be honest, not really to that very often. Let's look at the other way to formulate this, the more generally easier way to deal with it. The other way to deal with this, who remembers what the idea of the other way of looking at this was? Don't really pick like another x, don't pick a whole other point x. Just go a little bit away from A. How far away from A am I going to go? H away. And then I'm going to let that distance go to 0. Now, on one level, that should sound exactly the same as this should. But it isn't. You'll see when we get the expression right now, it's not the same, right? The limit, x, as h goes to 0. So here's my A and f of A. Then I go a little bit away from it, A plus h. Oh, shit. Here's my f of A plus h. There's my 2 points, right? So here's my algebra, y2 minus y1 over x2 minus x1. And of course, what always happens on the bottom? The a's go away, right? That's how this is always going to work out when I do it this way, right? Just because the limit as h goes to 0 of f of A plus h minus f of A, all over h. So let's do something concrete with this damn thing. How's that sound? Right? You're like, yeah, let's stick with concrete as much as you can, Jeff. Well, shit, I can't always do that. So let's have a function. Let's do one of the most basic functions that's not linear. So let's do x squared. Yeah. And let's say I want to know. We want to know. By the way, if I ever say that again, it's going to be we want to know. Right. We want to know the slope of f of x at x equal to 2. Let's do it. I think it's one of the first things we did. We got the idea of this to be 4. I don't know if you guys remember this, like the first day. So let's apply that. This is the definition of the slope, and in calculus, the word for slope is derivative. So this is the definition of the derivative at a point A. Right? So in this case, what's A? X squared. No, that's f of x. What's A? 2. I like it. So this will be, so how do I set this up then? The limit as h goes to 0, f of a plus h minus f of a all over a plus, yeah, there you go. H. What will f of a plus h be? A is 2. That's going to be 2 plus h squared, which is what? Foil that thing out, what do you get? 4 plus 2h, 4h plus h squared. So that's f of a plus h is 4 plus 4h plus h squared. F of a, f of 2 is 4. Now, in general, do you see the problem with this? If h is 0, f of a minus f of a over 0 is 0 over 0 is indeterminate, right? What's about to happen is what happens most of the time, unless it's something freaky like sine or natural log or something really freaky. Do you see how anything without an h cancels? And then I can kill the problem? All right. So those kill each other. I can then, so I get the limit as h goes to 0 of 4 plus h, and of course that is 4. So the slope of x squared at 2 is 4. So a straight line, a tangent line going through that point will have a slope of 4. So let me see if I can push this a little bit. Before I push it a little bit, anybody have trouble with any part of this? I would think if I were you, I'm like, oh, thank God, something I can sink my teeth into. I can plug shit in. I can do this shit. Thank God. Instead of all this theorem and all this kind of crap. I would think that's how you would feel. That's how I would feel if I was one of you right now. The next kind of level, coming right off of what we just did, is can you find the equation of the tangent line? So what do we have so far? We have that big, make that big. So right there, we just figured out the slope is 4. What point does it go through? Two, 4. So at that point, meaning that's the only point that the tangent line touches, and if something was following that track and suddenly it just came off the rails, it would follow that tangent line. So like when I was swinging that thing around and everybody in front row was like, you better hold on to that damn thing. So now this is algebra, right? M is 4. I got my point 2, 4. I can use either thing I want to, but just to kind of reinforce this dude for later, I can use that guy, right? So this would be y minus the y piece equals 4 times x minus the x piece. So you go y equals 4x minus 8 plus 4, so minus 4. And that kind of jives with my gross little picture here. It looks like maybe it's going to hit, especially if my scale is better. It's going to hit down there at negative 4. Is that cool for the y-intercept? That is the line that has the same slope at this point and touches it only at that point. That's the tangent line. Okay, I like it. Let's do another one. And let me do this. Let's do one more just like this, and then I want to show you the more general idea, and then I'll stick to my promise to let us out a decent amount early. Let me see. Okay, has everybody got what they want here? Okay. If you guys can handle this one, what about f of x equals 1 over x? At x equal to 1/2. I love it. So try to do that. What's a again here? 1/2. Cool. So you could do well. So this will be more specifically I'm so evil. A little fracception going on. Fraction inside of a fraction. What is f of 1/2 plus h is just? I think you guys just don't like talking to me, which is really going to make this semester rough. Just plug 1/2 plus h in, right? 1 over 1/2 plus h. What's f of 1/2? Yeah, 1 over 1/2 is 2 all over h. Now what can you do with this? I mean, there's one little thing you can do with this if you don't like a fraction inside of a fraction. You've got two sides, top side, bottom side. You're allowed to multiply to kill stuff if you want to. I'm not sure where you guys went with it from here, if anywhere. But one thing I would do is I would double top and bottom here. So they don't have a fraction inside of a fraction. It's totally your choice. Is that decent? Totally allowed to do that. I can multiply top and bottom of a fraction by any damn thing I want to except 0. Now, of course, what do I need? Lie denominator. So this has got a 1 so far. So it needs a 1 plus 2h. So let's see what happens here again. Limit as h goes to 0 of 2 minus 2 minus 4h all over 1 plus 2h. Is that cool? All that over h. And then what happens? This is not too bad. Hopefully it's not too bad. Are you guys, I've noticed that, and this isn't necessarily your fault, but some fundamentally easy things are kind of like made to be so difficult. What's a slightly better way to write this? I mean, this divided by h is this times 1 over h, so I can just put that stupid h there. Right? Huh? Yeah, of course, and then Tommy do that. So it'll be negative 4h over h times 1 plus 2h. That's... I'm getting some neat looks. Again, this fraction divided by this is this fraction times 1 over this, so that just goes there. Another way to look at it is I'm dividing this by this and this. There. Do you guys see what I just said? I'm dividing this by this and this. There you go. Much better way to write that, because now I can just really see easily that what happens. The problem cancels, right? What's the problem? The stupid h. That's what's making the top and bottom all 0. I'm getting indeterminate form. Die. Now it's completely determinate. Yeah, plug 0 in for h. What do you get? Yeah, you get negative 4. And why does that make sense? Does anybody know? Please tell me you know what 1 over x looks like. What's that function look like? Is the most basic, well, it's basic in one sense. It's the most basic hyperbola. In another sense, it's not basic at all because it's a diagonalized hyperbola. So it's this guy, right, where this guy is still a function. So I'm at 1/2, so I'm like here. So it makes sense the slope is negative, right? Because this would be 1, because that's where 1 over 1 is 1. It's amazing. So that's 1 at the curve. I'm back here, so I should have a big negative slope. So negative 4 slope makes total sense. This is what pre-calc's job is to hammer all the forms of all these things in your head, so when you're doing calculus, they're right there for you, so you can make immediate sense of what you're doing. And now a lot of you guys are looking at me like, well, that was 7 years ago, or whatever. I'm sure it was there then, right? But I'm just telling you, I'm going to put it back in there. So if I wanted to get the tangent line equation, what information do I know to get that? I know that. What about negative 4? What is that? Slope. M is negative 4 at x equal to 1/2. Right? So for the tangent line, though, it's just everywhere. It goes through the points. What points does it go through? 1/2? 2. So just plug a 1/2 in, flip it. So then I got y minus the y piece equals m times x minus the x piece. So y equals negative 4x plus 2 plus 2. And let's see why that makes sense. The tangent line is going to look something like that. So it does look like it's going to go up here and hit maybe up here 4. And it does have a decently big negative slope. So that makes sense, even with my shitty ass little graph there. But I like it. So this is the kind of thing you do, even if the problem doesn't say sketch a graph. Sometimes you're going to want to sketch a graph just to make sure things make sense. All right, so here's the last thing for today. Yeah, some guys are like, yeah. We've done a decent amount. Oh yeah, okay, I can. If I don't make x equal a, see how this goes directly to the slope at 1/2. What if I wanted the slope at 3 instead? I'd have to redo all this shit, wouldn't I? What if I wanted the slope at negative 1? I've got to redo all that. Wouldn't I rather do it once where x is just freaking x, and then I can plug whatever I want to it? So I don't have to do this whole thing over and over and over again. So section 2.7 is this. And then they make section 2.8. Let's just figure out the freaking slope function, right? If I redid this with a equal to 1/4, would I get the same slope? Hell no, because isn't it kind of curving back and back? It's going to be much bigger negative then. Do you guys see that? At 1/4, it's going to be much bigger negative. Yes?
It's going to be like on the test, so there'd be some questions where you're going to make us use that particular form, or in any case, can we use the nicer one you like to use right now?
I think you're getting a little too optimistic. Do you know like some derivatives?
Yeah.
All right, you're ahead of me. This is still going to be limit definition. It's just instead of using 1/2, I'm just going to put an x here. Yeah, the shortcuts for just doing quick derivative rules is coming, but it's not here yet. I like it. So there will be a day very soon when we pretty much stop using limits to calculate slopes, derivatives. We're going to start to see patterns from this and then build on those patterns. So we don't have to always use limit definition, because this is gross, but informative, right? And even if you don't think so, I don't care. I know so. So what if I want to find? Let me show you the. Here's the notation for derivative. Find the slope function, which I won't call it that anymore. I'm going to call it derivative. Find the derivative of f of x equals, let's see, what other kind of function? Yeah, let's do square root of x. I like it. The symbol for it is f prime of x. That's how you say this. This little line here. It's not a 1. It's a little, let's see if I can do this better. A little, whoop, or like apostrophe almost. So if you found the slope of the slope, you'd have two little things. That would be so in the news, every now and again, you'll hear something like, the economy is still getting worse, but not as quickly as before. That's a second derivative. The slope is still down, but it's not as down as it was. We're hoping to God we're going to do this and not this, right? So you hear that all the time. The rate of change is not as much. Okay, that's like a second derivative. That's the slope. That's how quickly the slope itself is changing. So that's in our future. So this is what I'm going to focus on right now. So using the limit definition, just to make sure that there's no, we're still doing that. So to do that, I just don't use a's. I just use x. Where'd you go? There you are. So I'd say the limit, as h goes to 0, f of x plus h minus f of x all over h. What is f of x plus h?
The root of x plus h?
No, what's f of x plus h? I'm sorry, oh, you said the root. I'm sorry. I thought you said the derivative. I was like, wait a minute. All right, so the square root, x plus h, I like it. And of course, f of x is rad x all over h. Now, definitely now, you know what you got to do here. Conjugate, I love it. All right, conjugate, yes. So if you multiply by square root of x plus h, sorry, plus square root of x. And on the same thing on the bottom. What do you get? Headache. No, you get minus x, you get h over h times square root of x plus h plus square root of x. Now that is intriguing. So these cancel. And so the problem canceled, which means I'm allowed to plug the value in now. I got rid of the problem that was keeping me from doing that. Now I do it. And when I plug 0 in, what do I get? When I plug a 0 in for h, because I can do that now. It's not indeterminate anymore. I can determine the answer. What do you get? 1 over square root of x plus square root of x, so 2 square root of x. Now again, I know some of you guys have taken some calculus before. I know you know the power rule. You better not be using that shit when you're not supposed to be. I don't care you got the answer. In this case, you need to understand the limit definition. Yes?
A question that was kind of similar to a previously asked one. So instead of using the rules that you're saying, like, can we use the limit of the definition rule as opposed to the A rule where we have a point that we plug in to find the later one? Can we just start with the limit of definition where we plug
For me, I'm going to let you do that.
Okay.
For the homework, you should do what they want you to do. Yeah, just to see how it works both ways. But can you understand now? If I wanted, so let me just write this last thing then. What did we just show? F prime of x is 1 over 2 rad x. So if I wanted to know the slope of the square root of x at 4, what would I do? That would look like this, f prime of 4. That means the slope of the function at 4.
So 1 over 3.
So it would be 1 over 2 square root of 4, so you get 1 4. If I want to know the slope of square root of x at 16 or whatever, right? I can just do it really quickly. I do that once. I get a function of x, and then I can attack it. I like it. Now, last point I want to make. This is a function in its own right. What I mean by that is, just because I got it from taking the derivative of rad x, doesn't mean that it depends on rad x to its x. This is its own function. It happens to be the slope of rad x. It's got a function who is the slope of this. I could do everything we just did to figure out this. I could throw that function into here, do it, figure out the slope of this function. You guys see what I'm saying? When you apply a slope process, you create a new function. It happens to be the slope of the original function, but it's its own frickin' function. You can do a slope of it, right? It would happen to be the second derivative of the rad if you did it one more time, but it is this guy's slope. He's his own little function. Poor little dude. The second half of this course is doing this backwards. I give you a function and you figure out where it came from. Not surprisingly, the first word we use for that process is antiderivative. If this is derivative, backwards should be antiderivative. That's very, we're very creative people, Matthew. Antiderivative. That sounds good. So that, we actually just made it through 2.8, sort of. We just kind of surface did it. So next time we're going to do deeper stuff in 2.7, 2.8. Get a little bit into chapter 3. Probably have a handout related to the quiz that's going to happen on Monday, just as a review. Cool. So that'll be tomorrow. We're going to get out here really early today. Yeah, don't get anywhere near used to this. I just felt like we probably could all use it, so enjoy it. Oh, real quick. Does anybody not know where the Math Study Center is that wants me to show them real quick? If you got a minute? Or you want to... It's up to you. I was going to take everybody, but I think a lot of you guys know where it is already.
I'll figure it out.
Anybody really not sure they can find it on their own wants me to show them where it is? I normally take a little field trip, but it's a little warm, so I don't know if everybody want to do that. I love you guys. You're all like, I just want to get out of here and away from you, Jeff. I understand. I won't take it personally.